Hi class, so today we will continue our chapter 8, Kingdom of Animalia, but today we will focusing on on coelomate animals, which is Phylum Mollusca, Annelids, Arthropods, and also Echinodermata. So remember, variation in body plans in animal, including the coelom, which is some animals do have coelom, that known as coelomate animals. So, some animals have a full coelom, that known as pseudocoelom, and some animals also do not have a coelom at all, that known as a coelomate animal. So we have learned already on the coelomate animals and also pseudocoelomate animals, but today we will learn on the coelomate animals. So we know already that coelomate animals are triboplastics, meaning to say they have three types of tissue called as the ectoderm, endoderm, and also mesoderm. So, coelomate animals can be divided into two main groups, which is protostomes and also deuterostomes. So, protostome, including phylum of mollusks, annelids, and arthropods that have a same feeding organ, which is lophophores. And the next group is known as deuterostomes, including the phylum of echinoderms, Echinodermata, and Chordata. So, the first group, which is protostome. So, the early embryonic cell division in protostome are angle, which is called as a spiral cleavage. In the ball-shaped early embryo, the first indentations, as you can see over here, the first indent, known as the blastopore, will become the mouth. So the coelom will form from tissue at the sides of the gut near the blastopore. Meanwhile, for the second group, which is deuterostome are characterized by the radial cleavage, different with protostome, which is by spiral cleavage, but this one is radial cleavage, meaning to say the zygote divides symmetrically. So the blastopore will become anus, different with protostome, which is the blastopore will become mouth, and in deuterostome, the mouth will develop from the second opening. So the first opening is the anus. So the coelom forms from the outpouchings of the gut wall. Okay, as you can see here, the first blastopore will forming the anus, not the mouth. Okay, as you can see over here, the differences between protostome group and also deuterostome group, which is first look at the cleavage. Protostome is spiral cleavage, meanwhile for deuterostome is radial cleavage. How about the coelom formation? Coelom formation in protostome split and form a coelom. Meanwhile, in deuterostome, they do not split, however, they will fold to form the coelom. And the first blastopores in the protostome will producing the mouth, and meanwhile the first blastopore in deuterostome will producing or not producing will forming the anus. So in the first group, okay, which is um, in the first group, which is the lophophores, they have three phyla under them, which are phylum Ectopropta, phylum Poronida, and phylum Brachiopoda. Okay, so all of these three phylum possess the same feeding organ, which is known as lophophore. As you can see here, this one is called as a lophophore. So the lophophores can most easily be described as a ring of tentacles. Here is a lot of tentacle forming a ring, but it is often horseshoe crab or coil in shape. Horseshoe shape, not crab. Horseshoe shape or coil. So the member of Lophophorids are a coelomate as are coelomate animals, meaning to say they do have a coelom under the group of protostome, and the mouth is always located inside the lopophore rings of tentacle. Meanwhile, the anus lies outside the ring. So the lopophore's tentacle are covered with cilia in a specific arrangement that are responsible for generating a current water that flow toward the mouth. And they are also sessile animals with adaptation like U-shaped digestive tract and absence of the head. Therefore, they are not showing the characteristic of being cephalized. Okay, as you can see over here, the lophophore, the ring of the tentacles, known as lophophores. So the first phylum under Lophophores, phylum Ectoprocta. So Ectoprocta is a colonial animals that resemble plants. So they are encased in a hard exoskeletons with pores for lopopores extension and mostly live in the marine habitat like the reef builder. For the second phylum under Lophophorids um, is Poronites or phylum Poronida. They are tube-dwelling marine worms, and the Lophophore will not be coiled whenever threatened. And this member of this phylum are elongated and worm-shaped, but the gut loops and end close to the mouth instead of passing straight through the body. The next phylum under Lophophorids is phylum of Brachiopoda, and the member is known as the brachiopods. They're also known as a lamb shell, as you can see over here. They are sessile. They have two shells and they are marine animal with an external morphology that resemble the clam. Okay, and the brachiopods are the suspension feeder with a distinctive feeding organ called lopopores because they're under groups of lopoporids. Okay, so the brachiopods resemble clams and other hinge shell mollusks. However, their shell are dorsal and ventral rather than in clams. Clams, the shell are lateral. Both are lateral. Next, we're gonna look on the second phylum and the group of protostome, which is phylum Mollusca. Phylum Mollusca includes the snail, slug, oyster, clam, octopus, and also the squid. And most of the mollusks are marine, and only some of them living in the freshwater and also terrestrial. Mollusks are very soft-bodied animal. That's why they're known as a mollusk. But most of them are protected by a very hard shell. As I mentioned earlier, mollusca means soft body. So mollusks are the second largest invertebrate group. The first largest the largest invertebrate groups are phylum Arthropods. Okay, remember. So phylum mollusks are protostome with bilateral body symmetry. They have a tubular gut in their digestive system and they do not possess any segmentation. So features that common between them usually include a head, a broad and fleshy foot for locomotion, a dorsal and ventral shell, a mantle. They do have a mantle, okay, and to secrete the calcium carbonate and protein to produce the shell. They also possess gills, or known as cnidia, as a respiratory organ, and also they do have radula for feeding. Okay, as you can see here, this one is a mantle, the one that producing calcium carbonate to form the shell of the mollusk. So under phylum of mollusks, there are four major classes, which is the first one is Polyplacophora, second is Gastropod, the third one is bivalve, and also Cephalopoda. So gastropods, which literally means belly food, as you can see over here. This refers to the way a mollusk food spread out when it crawls like a snail, okay, and like a snail over here, and also like a slug, and they also have coil shell, okay, that function as a backpack for balancing, such as in snail. For a class of Polyplacophora, such as a chitin here, okay, the kittens are very slow moving bracers which have 8 plate shells covering the dorsal body, and their head is being reduced and the lack of eyes and tentacle. For class of bivalvia, animals that having two valve shells such as the clams, scallops, oyster, and also mussels. The fourth class of phylum mollusks are cephalopods, such as the squid, the octopus, which are swift-moving and very smart member of the phylum, which is the octopus. Okay, this is a figure of gastropods, Polyplacophora, class of Bivalvia, and also cephalopods. So Phylum mollusk is very unique because due to their soft body that protected by the shell, the member can undergo different modification with their body plan. So the first modification is they can twist and detwisting their soft body. So such as in the snail, the bilateral gastropod larva develop one side of the body grow more rapidly than the other sides. As a result, the internal organ undergo a very unique twisting and a torsion at 180 degrees that will place the anus anteriorly near the mouth. So the anus is located near the mouth. So this might be an adaptation that will protect the head from the predator. So they will withdraw their head into the shell when they are being attacked by the predator. So without the torsion, the feet would enter first. But however, this one, the head is enter first inside the shell. Okay, as you can see over here, this is before the torsion. Okay, and this is after the torsion. The mouth and the anus located in front and near to each other, and they will pull in into the shell when they're being attacked by the predator. The second the second modification in mollusk body plants is the way they hiding out one way or another. So such as in class of Polyplacophora, the kittens is protected by the 8 plaque shells around the soft edible body. So when they are being disturbed, the muscle in the foot will pull the body mass down, so they will create a very great vacuum suction power against the rock, as you can see here. So they will attach to the rock, so it will hard for the predator or other animals to pull them off from the rock. That is the way how they protect themselves. Next is they are suspension feeder. Bivalvia or the bivalve not only has its two protected shell, such as the clam, oyster, and also the mollusk, but also they can burrow in the sand to disappear from the sight of predator. So they are suspension feeder that will trap the food particle in the seawater. They are two opening called as a siphon, where water and suspended food are drawn through the in-current siphon, and the waste will be excreted out through the other opening, which is the ex-current siphon. Okay, the in-current siphon to draw in the suspended food. Meanwhile, the ex-current siphon to draw out the waste from the body. So the food was trapped by the mucus, secreted by the gills, and by the actions of the cilia on the gills. So the food will move to the mouth. Okay, as you can see here, this one is referred to the in-current siphon that will draw in this. This side will draw in the food particle, and ex-current siphon helps to excrete out the waste from the body, and they are hiding themselves in the sand. Next is mollusks possess tentacles and a beak-like jaws. Okay, so in the class of cephalopods, their body is modified for an active predatory lifestyle in which they have tentacles and also a beak-like jaws. Their tentacles are covered with sucker to catch prey, as you can see over here. Okay, such as the squids and also the cuttlefish. Their mouth has two strong beaks that used to kill their prey and tear them into pieces. So their body is lack of calcium carbonate shells. Okay. So next is some classes of phylum mollusks have a thick and muscular mantles. Okay. So their mantle is thick and muscular and fitted with a funnel like a siphon. So by filling the cavity with water and ejecting the water also through the siphon, the cephalopods, which such as the squid, octopus, and cuttlefish, can move by jet propulsion. Next is they also can change color and discharging dark fluids such as the class of Cephalopoda. Cephalopods have extra adaptation beside the jet propulsion that I mentioned just now to confuse the predator, in which they're able to change their color, meaning to say they camouflage with the environment, and they will discharge a dark fluid or a dark ink from the insects so that they can escape themselves from the sight of the predator. Okay, and also the last one is that they have a closed circulatory system. So to support greater activity, the circulatory system is closed with a heart. So beside that, the nervous system is well developed with a large brain. So the eyes could form image causing a learning and memory become possible for them, such as the squid. Okay, so this is the conclusion for the four classes in phylum Mollusca. You can read by yourself later. Next, we're gonna look on the phylum Annelids, also in the group of protostome. So Annelids can be divided into three classes, which is class Oligocetae, class Polyceta, and class Hirudinae. So they are also protostome, okay, as I mentioned earlier, because they form a spiral holoblastic cleavage, and they also have a bilateral body symmetry, a tubular gut in their digestive system, and they possess segmentation. Okay, different with phylum mollusks just now. Phylum mollusks do not have segmentation. Meanwhile, phylum Annelids do have segmentations. Okay, so but however, these two have a similar bilateral body symmetry and also tubular gut. So Annelids habitats include terrestrial, freshwater, and also marine. So the segments in Annelids make up their identity are usually referred to as a ring. They're forming a ring in their body. many of their internal organs, such as the metanephridia, which refer to osmoregulatory organ, are segmented also. However, structure like digestive tract and certain nerves extend throughout their body. So this is how does the groups of annelids look like. I will explain more details. So what is the advantages of segmentation in phylum Annelids? So a segmented body has great evolutionary potential because each of the individual segment parts can undergo different modification and become highly adapted for specialized tasks, especially for locomotion. So for the class of Oligoseta and Polyseta, they possess a setae and also a bristle that will project directly from highly segmented body, and it is chitin reinforced. Okay, so in the soil it helps them to crawl and also to burrow themselves. And also class of Hirudinae, such as the leech, they have a sucker at both ends of their body. Okay. Meanwhile, for Polyseta, they have a fleshy paddle-like parapods above the bristles. Okay. So the earthworm in the class of Oligoseta bear few short setae for each segment compared to Polysetae. Okay, and the gut extend through all the chamber. Over here, the gut extend all through all the chamber, and the body is enclosed in a flexible and permeable cuticle. The cuticle over here, okay, the cuticle is on the epidermis, that is good for gas exchange. And the earthworm in the group of class Oligosetae respire through the skin. However, this cuticle of the earthworms is not good for water conservation, causing them to be restricted in aquatic and moist habitat. Their habit of ingesting the dirt particles while scavenging for organic matter makes them valuable tiller for the soil. Very good to make a compost. So when they burrow and feed, they collectively aerate the soil and lift the nutrient to the surface, therefore benefit the plants to get the nutrients from the lifting nutrient on the surface. And also, the class of Oligosetae in phylum Annelids, they have internal partitions that define individual coelomic chamber filled with fluid to provide a hydrostatic skeleton for them. So they have a hydrostatic skeleton, okay, a skeleton that makes they do not have a bone, but they have a fluid, okay, in their body. So the coelomic chamber, together with circular muscles, longitudinal muscle, and setae, will allow the typical earthworm pattern of movement. And they also have a pair nerve cord. Okay, here, this is the nerve cord that extend from their brain. Okay, and to run the length of the body with ganglion in each segment. Meanwhile, their circulatory segment is a closed circulatory system. So meaning to say, closed circulatory system is that the blood is confined in a vessel to, in the case of Oligosetae, to multiple heart and also vessel. They also contain osmoregulatory system, which is metanephridia, as I mentioned earlier, which occur in nearly every segment in the body to regulate the volume and compositions of body fluid. So each unit has a funnel, which is known as nephrostomy, that will collect the excess fluid and deliver to the bladder, which leads to a pore called as nephridiospores that will help to excrete the excess water. So remember, nephridiospore is the one that helps to excrete the excess water from the earthworm body. And remember also, the earthworm are hermaphrodites, meaning to say they have both sexes in one body. And however, the two earthworm can line up in a head to tail fashion, as you can see in the figure here. Okay, and they will exchange their spermatozoa or sperm. So meaning to say, both of the the earthworm will fertilize later. Okay, because both of them do have the eggs, and they exchange the sperm to fertilize the eggs inside their body. And also, they have a network of capillaries that envelopes each collecting tubule of metanephridium. So this capillary of metanephridium will reabsorb essential salt that come out of the collecting tubes. Okay, so you can see here, this is the nephrostomy, nephridiopo, the one that used to excrete the excess waste, and this one is the collecting tube. Okay, to reabsorb, same with our collecting duct in our kidney. Okay, to reabsorb the essential salt. So next, we're gonna look on the class of Polychaetae of phylum Annelids. They consist of marine worms that are free-living, and some of them burrow in the mud near the shore or live inside the tube. So they're fleshy, paddle-like parapods. This one is a parapod. Okay, function in gas exchange and also locomotion. So this structure bear many setae, and they have a well-developed head with tentacles and the phylum. Meanwhile, for the class Hirudina, under the phylum Annelids, mostly sucking parasites such as the leech. Okay, the leeches. They do not possess any setae for movement, such as the earthworm, and also they do not possess parapodia that you can found in Polychaetae. Instead, the anterior and posterior sucker are the unique characteristic for them. Okay, so this is the conclusion, or the short notes for the three classes under the phylum Annelids. You can read by yourself later. Okay.